summarization, it also called route aggregation or supernetting. It allows routing protocol to advertise many networks as one address. The purpose of this is to reduce the size of routing table on routers to save memory. For example, in subnetting, we divided a network into some subnetworks. That is subnetwork 1, that is subnetwork 2, that is subnetwork 3, and so on. But in summarization, we summarize multiple subnetworks or networks into one network. It helps the router to save the memory, because if router save these three networks, then it need more memory. Instead of saving these three networks, router save only this one network. For example, in RIP routing protocol or any other routing protocol, there is a command that is network, that is used for advertising network. For every network, we need to give a command. For this network, we need a command that is command 1. For this network, we need to give a command that is network command 2. And for this network, we need to give a separate command that is command 3. But if we are using summarization or supernetting, then we collab these three networks and introduce these three networks into one network. So in the case of summarization, we need to give only one command. This is the benefit of summarization or supernetting. For example, I am having a network like 10.0.0.0 and 10.1.0.0, 10.2.0.0, so on till 10.255.0.0. So we need to give commands for each network separately. Here I am having 256 networks. The first network, second network, third network, and so on till this network. We have 256 networks, so we need to give 256 commands. But we summarize this network into a particular network. This is a summarized network, that also called summary. This is the summary network of all these networks. So we need to give only one command instead of 256 command. In this case, we have 10.0.0.0, 10.1.0.0, 10.2.0.0, and so on till 10. This is 10.255.0.0. So the summarized address is 10.0.0.0/16. These all are /8. How we can calculate the summarized network? For knowing this, let's take the step by step process. First, check all networks. First check the first octet is same or not. If first octet is same, then put that octet in summary address also. This is our resultant summary address, because all networks have same first octet, so the summary address also have 10 or same as all networks. Now the second octet is different for all networks. Now write the second octet's binary value. Change second octet into binary value. For first network, the binary value is this for first network. For second network, the binary value is this. For next network, the binary value is, and so on till last 255 network. The binary value is what are the common in this all networks. The first bit is not common because here I have 0, here is the 1. So this bit is not common. So we use minimum value. The minimum is 0 for binary. So we use minimum values here. The second octet becomes 0. The rest octet also becomes 0 slash 16. This is the summary address. Now take a better and another example for better understanding of summarization. We have some networks, that is 172.16.12.0. It has slash 24 network. Now 172.16.13.0 slash 24, 172.16.14.0 slash 24. Now 172.16.15.0 slash 24. We have 4 networks, and now we need to summarize these all networks, or we need to do supernetting for these all networks. So let's start. We need to check the first octet. First octet are common in all networks. So in summary address, the first octet is as it is because the first octet is common for all networks. The second octet is also common for all networks. So we put this 16 here because these all networks having same or as it is second octet or common second octet. So we use this here. In third octet is not common for all networks, so we need to change third octet into binary format. For 12, the binary value is 0, 0, 0, 0, 1, 1, 0, 0. This is 12 in binary format. Now the 13, the binary format is 0, 0, 0, 0, 1, 1, 0, 1. For 14, the binary value is 0, 0, 0, 0, 1, 1, 1, 0. For 15, the binary value is 0, 0, 0, 0, 1, 1, 1, 1. This is a binary value of third octet of each network. So let's check how many bits are common. We start from here, from this end. The first bit is common, the second bit also common, third also, fourth also, fifth bit is also common, sixth bit is also common, but 7 bit have differences. So we separate 6 bits from remaining bits. The common bits are 0 0 0 0 1 1. All remaining 2 bits are become minimum. The minimum value for binary is 0, so we put 0. This is our third octet of summary address. Now we change this into decimals. After changing the decimals, this becomes 12. So the third octet becomes 12 and the fourth octet is 0. Now, now let's check the CIDR value. How many CIDR we use here? 8, 8 bits here, 8 bits here. These 8 bits are common in all networks. These 8 bits are common in all networks, and here only 6 bits are common in all networks. So we use 8 plus 8 plus 6. That becomes 22. So the summary address becomes 172 that are common in all networks, 16 that are common in all networks, 12. 12 means starting 6 bits are common in all networks. Here we calculate the 6 bits. So we use 12 here and now 0. The CIDR becomes 22 because starting 22 bits. Starting 22 bits. I am talking about starting. So we need to calculate or we need to count bits from here, not from here. We need to start from this end. So starting 22 bits are same or common for all networks. So we use 22. This is the summary address that summarize this is the summary address this is the summary address that summarized all 4 networks. Now if we give this address to any routing protocol, then all that routing protocol is applied to all these networks because these all networks are summarized as this. This is all about summarization, or you can say route aggregation or supernetting.